Hi, everybody. My name is Alexandre Matton. I'm an ML engineer at Cohere, and I'm very excited to be here to talk about how we can bootstrap NLP applications with large language models. So during this talk, I will first explain what a large language model is, how we can use them, and then we'll deep dive inside like some very common use cases in industry that can be directly empowered through using large language models. Finally, I will also show some more advanced use cases, which basically entail using large language models to generate synthetic data and improve machine learning pipeline. So first, what is a large language model? So to sum up very quickly, a large language model is a neural network. It's a very big neural network, and it has been trained on a very big size of the internet. Thanks to that, it can understand text and accomplish a lot of different text-related tasks, like, for instance, writing very fluent text, extracting some information, classifying some information, and all of this work directly out of the box. Deploying large language model is a pretty hard task because these models are very huge, so they need clusters of computers to be deployed. So what this means is that developers generally use them through APIs. Actually, for the developer, it makes it very easy because it's only a few lines of code and you can directly use most of the functionalities out of the box. So here I just copy pasted a small screenshot of how it looked like. So for instance, you just need to insert your API key, and then you can, in one line, choose a model to generate from, choose a prompt, which is basically the input of the model. So to explain to the model what it has to do, fix a couple of parameters like the size of the output, things like that, and you get an output in a couple of seconds. You can do this as many times as you want. And so as you can see, it's a very, very minimal setup. Now that we've seen that, let's talk about some of the use cases that are enabled by this technology. The first one, as you saw in the last slide, is text generation. It's kind of the main use case because that's how large language models were trained. So basically, you can ask a large language model to write about anything with the formality level that you want, the length that you want, and then it should be able to produce some fluent text corresponding to your ask. So here I just asked the model to write something which looks like a LinkedIn post about starting your career in tech. And you can see that the output is a text which is pretty fluent and kind of corresponds to what you would see on LinkedIn about that. If you don't like the answer, the great thing is that the output is random, so you can regenerate a new answer until you're satisfied with it. As you can see, with text generation, there's already a lot of things you can do. It doesn't have to be a LinkedIn post, it can be really anything. And so it really helps you to write text faster. A second use case, which is very dominant in the industry, is text classification. So what I did here is I built very quickly a small spam classifier. The way I did that was to put several examples in my prompt. So here I wrote a sentence. Hey, John, it's Emily, how are you doing? And I said that the category was not spam. Then I wrote another sentence, this one corresponding to a spam, and I put spam as the category. For the last sentence, which is the one I want the model to classify, I wrote the sentence, but I didn't fill in the category. Because large language models learn how to complete the text, the large language model I'm using knows that it has to fill in the blank, and that's what it's doing. And as you can see, the output is spam here. So what this means is basically in really a couple of sentences, I was able to make the large language model understand that what it has to do is to classify text into spam or not spam. Finally, a last very common use case is extraction. Here, I took a very generic example. What I did was copy pasting a paragraph about Paris from Wikipedia, and I asked the model to extract all the cities that appear in the text. You can verify, like the 2 cities that appear in this text are Paris and London. It was able to do that. Obviously, you can do this with a lot of different examples. You could ask a model to extract, I don't know, let's say like prices that you see in a text, to extract the sender of an email, to extract a lot of different information. And so there are a lot of use cases that are enabled by this technology. So here, the 3 use cases I just showed you are pretty straightforward, very simple. And the great thing is that you don't need any machine learning knowledge to make them work. You don't need any expensive setups. You don't need to create training data or anything. And it works directly out of the box with a very good accuracy. If you want, you can also use large language models for more advanced use cases. And here are some examples where we use them to actually generate synthetic data, which is going to help us to build other machine learning models. Why would we do that, given large language models are already like very good machine learning models in themselves? There are several reasons to do that. The first one is that large language models, as I explained before, are huge. So they're huge, which means they're costly, and also they're a bit slow. What you could do is to use large language models to generate training data, so that you'll be able to train smaller machine learning models that are much cheaper, much more efficient, and much faster. Another reason to use large language models and generate synthetic data is to diversify your training data set. In machine learning, we know that models robustness is very important. And to improve this robustness, we need to diversify the example we have in our data. And large language models are a very simple way to do that. You'll see that in the next slide. Finally, the last use case that I thought of with synthetic data is using large language model to create data for tasks that they cannot solve. For instance, let's say the task at hand is to search relevant sentences in a database. Large language models can't really do that because they can't read the whole database, and usually you have to use very specialized models. However, to use these models, you need to train them first, and that's where the large language model can be used. So to make all this clearer, let's deep dive into 2 more use cases. The first one is spam detection. So let's go back to like our spam detection idea. As we saw a couple of minutes ago, we can directly use a large language model to create like as a spam detection system. But if we want a solution which is simpler and in-house, we can like train a small model to do that. To train it, we need data. So we need spam data, which is data that we might not have at hand easily. So what we can do is ask the large language model to generate this data. So here I asked the large language model to generate 5 examples of spam messages related to companies selling clothes. And so here you can see like the model outputs 5 different messages that are pretty diversified. The great thing with that is that I can cherry pick them, which means I can take the one I like and throw away the one I dislike. And also like I can just ask to like generate more and more until my training data is big enough. So as you can see, this is a very easy way to generate a lot of training data. It's much easier to do that than having to like come up with data ourselves. And so that's a way to like build an ML pipeline very quickly and making sure that it's going to be robust by improving the quality, the diversity of our data. The second use case of this synthetic generation that I want to talk about is improving search models. So here, just to give you a little bit of background, search models are models that match a query with a corresponding document or corresponding text in a collection of passages. There are a lot of search models actually deployed in production that are very useful. For instance, for e-commerce websites, where you might like customers might input a query, let's say blue sweater, and then the e-commerce website has to find all the items that correspond to this query. So to train models like that, you need all the passages, all the documents. So an e-commerce an e-commerce website will have like all the items already available, but you also need relevant queries. If you're a new website, you might not have queries yet for the customers. So one idea is actually to use the large language model to already generate relevant queries, which will help you to train the machine learning search model already without having interacted with customers yet. So here I give a very simple example where I took a passage from Wikipedia and I just asked my large language model to generate a question out of this passage. So for an e-commerce website, you could do that by basically as input giving a description of a product and as output asking the model to generate a query for this description. So that was all the use case I wanted to talk about. Here are some conclusions to sum up what I said earlier. First of all, large language models are a recent technology that, as you can see, can enable any developer to very quickly and very easily incorporate text understanding tasks like classification, like extraction to their project. What's great about them is you don't need any knowledge in machine learning. You can do that extremely easily in 5 minutes. So no need for all the machine learning data and pipeline to be set up. Moreover, you can use them for more advanced use cases like generating synthetic data, which will help you to improve over-ML pipelines. Just a small disclaimer about large language model. Their output is not always safe, which means that sometimes they can be wrong if you ask them to do something specific. Sometimes they can output sentences that are biased and offensive. So large language models are not suited for all use cases. For instance, you should never show the output of a large language model directly to your customer without any verification or filtering first. However, there are still a lot of use cases where this technology can be directly applicable and solves use case very easily. Thank you so much for your time. I hope my presentation was clear, and I'll stay a little bit for the Q&A.